Imagine a future. Cars drive themselves, no traffic jams, no accidents, a world where you can sit back, relax, and let technology take the wheel. This is the dream of autonomous driving, a vision where efficiency and safety are paramount. But achieving this dream is hard, really hard. It requires overcoming numerous technical and logistical challenges. One of the biggest challenges, perception, understanding the environment in real time. Self-driving cars need to understand their surroundings perfectly. They must detect and interpret every detail. They need to see everything we see and more, from road signs to unexpected obstacles. This is where LiDAR comes in, a crucial technology for perception. LiDAR is like radar, but with lasers. It uses light to measure distances. It creates a three-dimensional map of the world around the car, a detailed, accurate representation. Think of it as the car's eyes, constantly scanning and interpreting the environment, but eyes alone are not enough. The car needs to make sense of what it sees. The car needs a brain to process what it sees, to make decisions based on the data. This is where deep neural networks, or DNNs, come in. They help the car learn and adapt.
Deep neural networks, or DNNs, are incredibly powerful computer programs. They have the ability to learn from vast amounts of data, adapting and improving over time. In the case of self-driving cars, we feed these DNNs massive amounts of LiDAR data, which is essentially a 3D representation of the environment around the vehicle. These DNNs learn to identify various objects within this data. They can distinguish between different types of objects with remarkable accuracy. For instance, they can spot cars, pedestrians, bicycles, and more, ensuring the vehicle navigates safely. They can even understand the layout of the road, sidewalks, and buildings, creating a detailed map of the surroundings.
There are two main ways DNNs utilize LiDAR data to make sense of the environment. The first method is called panoptic segmentation. This process is akin to coloring a picture. The DNN assigns a specific color to each point in the LiDAR data, indicating what type of object it represents, whether it's a car, a pedestrian, or a building. The second method is known as bird's eye view, or BEV object detection. Imagine looking down on the road from above. The DNN learns to find and track objects from this elevated perspective, providing a comprehensive view of the environment for safer navigation. These DNN approaches have made great progress, but they have limitations. One significant problem is perspective. Objects look different from different angles, which can be challenging for traditional systems. For instance, a car seen from the side looks very different from a car seen from the front, and this variation can confuse the system. Traditional DNNs can struggle with this variability in perspective. They might not recognize an object if it is seen from an unusual or unexpected angle, leading to potential errors.
Another significant problem is occlusion. Objects can be hidden behind other objects, making them difficult to detect. For example, a pedestrian might be hidden behind a parked car, suddenly emerging into view. Traditional DNNs can miss these hidden objects, failing to recognize them in time. And this can be dangerous, leading to near-miss incidents or even accidents.
Section 4. A new perspective, multi-view DNNs. To overcome these limitations, researchers are developing new, more powerful DNNs.
One promising approach is called multi-view DNNs. These DNNs don't just look at the LiDAR data from one perspective. They combine information from multiple views.
This gives them a more complete understanding of the scene. Imagine looking at an object from all sides. You would have a much better idea of what it is, right? That's the idea behind multi-view DNNs.
Section 5. Transforming views, transforming safety. But how do these multi-view DNNs actually work? They use a clever trick. They transform the LiDAR data between different views. For example, they can take the LiDAR data from the car's perspective and transform it into a bird's eye view. Or they can transform it into a view from the side. By doing this, the DNN can see the same object from multiple angles. This helps it to recognize the object more accurately, even if it is partially hidden or seen from an unusual angle.
Section 6. A safer future on the road. Multi-view DNNs are a major advance in LiDAR perception. They allow self-driving cars to see the world with greater accuracy and understanding.
This technology has the potential to make autonomous driving much safer. By overcoming the limitations of traditional DNNs, Multi-view DNNs can help prevent accidents and save lives.
The future of autonomous driving is still being written, but with advances like multi-view DNNs, we are one step closer to a future where cars drive themselves, and the roads are safer for everyone.